All right, this is day 3 of my 100 days of code. And today I thought I would do a puzzle on coding aim, or codin game, whichever you prefer. Guess they didn't want to have 2 G's. All right, so I'm going to go to practice puzzles. Let's do an easy one. There you go, 5 stars. That one looks interesting. Ghost legs. Ghost legs. What is that? Goal. What we'll learn. Conditions, loops, ASCII art. ASCII, I don't know how to pronounce that. Okay, goal. Ghost legs is a kind of lottery game common in Asia. It starts with a number of vertical lines. Between the lines there are random horizontal connectors binding all lines into a connected diagram like the one below. Yep, okay. To play the game, a player chooses a line in the top and follow it downwards. When a horizontal connector is encountered, he must follow the connector to turn to another vertical line and continue downwards. Repeat this until reaching the bottom of the diagram. In the example diagram, when you start from A, you will end up in 2. Start from A, 2, yeah. Starting from B up until 1C, 3. Goes back, okay. It is guaranteed that every top label will map to a unique bottom label. Right, okay. Given a ghost legs diagram, find out which top label is connected with which bottom label. List all connected pairs. Okay, let's do it. So I don't know if for those of you out there that have never seen the code and game platform, this is what it looks like when you're actually solving a puzzle. There's a embedded editor, which is decent, but I'm going to use an external editor. I'll show you how to do that in a second. Your test cases are here, and you know you've completed the puzzle. You've solved the puzzle when all test cases complete. And you've got more instructions here. We'll get back to that in a second. First, let's set up our project. So I created a little CLI tool because I was lazy. Didn't want to have to always set up my, I'm going to do this in TypeScript. This is JavaScript. They don't have TypeScript, out of the box TypeScript support, which means you have to, transpile your own TypeScript to JavaScript and push that to code and game. Okay, so what did I call this thing? Vitess, VTS, N for new, and we're going to call this ghost legs. And if it all goes well, it's supposed to basically take care of all the boilerplate, install the dependencies, and yay! See, generated new vanilla TypeScript project, Ghost Legs. Now let's see if it's true. Okay, so we got the directory. That's a good start. And let's open this in code. Yay! All right, good stuff. Everything seems to be here. Yeah, I got my roll up to bundle everything into one file, because you can only push one file to code and game. Okay, good. I'm going to do one thing though. I want to work in, my parent directory folder, because that's where my Git repo is. Oh, actually, coding games, Ghost legs, I'm gonna, yeah, see, automatically creates a Git repo too, my little CLI tool, but I don't want it at that level. I'm just gonna have, okay, there we go, that works. So let's call this add ghost legs puzzle. All right, and I think we're ready to go. Source main.ts. Oh yeah, there is one thing that we need to do for this to work. We need to go to settings, use external code editor, on choose a local file, projects, coding game, ghost legs, source. Oh no, actually I need to get the bundled, okay, so backtrack. Oh, here's what I'm gonna do. I'm gonna paste in this starting code that they supply you with, and right here, and then I'm going to, for some reason, okay, I'm going to npm, what's it called? I think dev. Dev will actually be watching, nope, I don't think, oh, that's because I'm not in the right, what was it, ghost legs, I think it was, ghost legs, yeah, ghost legs, and npm run dev. So this should be watching, yeah, all right, good. And see, it bundled everything into three different, got CGS format, ESM or UMD. I think CJS is going to be what we need here because code and game runs on Node. So let's try that. Settings, external editor, choose a local file, projects, coding game, ghost legs, dist, CJS, open, upload from local file, the coding game. All right. And, well, I don't know if it worked because I'm using the code that was supplied there, so let's change something. Yo. All right, so this ran. And go back here. Yo, all right. We're in business. And let's see. Just if we go play the first test case. Standard output stream. Yo, all right. Okay, now we're truly ready to get started. Let's read a bit more. So okay, so I read this, but line 1, input, line 1, integer, W and H for width and height of the diagram below. The diagram itself is composed of characters, whatever you call that. Is that a capital I or pipe or, and okay, and space. The top line is in the diagram has a number of labels. T. The bottom line contains labels B. Each T and B is a single ASCII character that can be of any random value. Do not assume they will always be A, B, C, or 1, 2, 3. Ah, okay. As a rule of the game, left and right horizontal connectors will never appear at the same point. As a rule of the game, left and right horizontal connectors will never appear at the same. Okay. So, yeah, I get it. Wait a minute. Width and height for width and height of the diagram below. So there could be more than 3 columns? Is that what I am to understand here? find out what the tests. Let's look at the test cases. Oh yeah, there you go. So, But then, if there's more than 3 lanes, what do they mean? When they say, as a rule of the game, left and right horizontal connectors will never appear at the same point. Well, they probably mean connectors that are next to each other, not completely to the left and completely to the right of the whole field. All diagrams are having the same style as the test cases. Okay. List all connected pairs between top and bottom labels, T, B, in the order of the top labels from left to right. Write each pair in a separate line. Oh, okay. Here's so a minimum of 3 in terms of width and a height of no more than 100. So if this is the input, output should be A2, B1, and C3 on separate lines. So we're going to need some kind of a loop, or I could use just new line characters, but we'll see. What am I missing here? What are those 7s here? Each T and B is okay. Next integer W and H for width and height. Oh, this would be width and height. 7, 7. So 1, 2, 3, 4, 5, 6, 7. Yeah, okay. 1, 2, 3, 4, 5, 6, 7. Get it. I get it. Now, how are we going to solve this? And this is coming in line by line. Okay. Let's take a look at the code we're given here. Look at it, my read line. Oh, read line is it's a global function that's supplied by coding games, so TypeScript doesn't know about it. Let's do, how does this work again? Declare function readline doesn't take anything and returns a string. You happy now? Yay, okay, good. var inputs, readline, split. So this should give us our width and height. Okay, right. We're taking those inputs. Yeah, for some reason my wireless headset disconnects once in a while. Okay, so yeah, so we're getting our width and we're getting our height here. And then this loop is var I is smaller than height. I plus var line. Okay, so we're reading each line. Then we got to parse each line and do something with it. Okay, let's think about this for a second. Our task is to get pairs. So in this instance here, just print the input first. Sure, it's already done. Well, I mean, not really. But as you command, that is a good idea. Just to make sure that it's coming in the way we're expecting it to be. right? Well, that's not actually that's our input that we've split into an array. But yeah, it works, 7, 7. So that's our first test case. If we look at the first test case, 7, 7. That's what we're supposed to be getting. Hmm. Oh, you want me to print each line? Sure. Let's do it. Console.log line. It gives us time to think about a solution. Sure. Let's get rid of all these semicolons. Apparently, don't need them in TypeScript. There we go. Oh, yeah, that's fine. This should be at the top, but because of the way we did it. Yeah, so we need to follow this down and figure out if we're, so as we're going down each line, we need to figure out whenever we get a connector, then switch to the next one, keep going down, keep testing for connectors on both sides until we reach the end. Hmm. Hmm, 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 hmm. Okay, so could use, I could make this into a two-dimensional array and have some kind of loop with an inner loop. It all gets crazy. So let's start by, okay, I gotta put this to the side here because but then I don't see you guys. Need a third screen. That's it. If I'm going to be streaming on Twitch, I need a third screen. Yeah, I really don't know how to start with this. Read line. If I read the first line will give me my labels, right? I should probably store that somewhere. Or should I just shove all of that into one big two-dimensional array? But thinking about solving problems makes for fascinating Twitch streams. uh, okay. Let's try this. Let's just start with an array. Aptly name array. We'll get back to that later. And we're going to push. No, hold on. What am I doing here? What is it? There we go. Array and dot push. No. That's not going to work. There's our array. Okay. Of strings. So let's do that. All right, see you, man. Could you paste the link to the coding game you are doing? Yeah, probably. I could probably do that. There we go. Just give me a second. I'll get that for you. All right, so we've got our array. We want to push our line. Push. Right there. Okay, so once that loop is done running, we've got an array of our strings. Now what? Now what? Oh, actually, that's not. Is that going to help us? Because now we've got. Hmm. Mm-mm-mm. I think I'm going to have to figure this one out on paper first. So let's get back to my thing here. So, then we start. We got to look below. Really what we have to do is look below and to the right as we're starting off. Actually, look below and to the left and right. It'll work. And then when we see a connector, we follow it and then keep going down. So basically we need to do two things. Look one index below and to the left, and one index below and to the right. So let's start with that. Let's start with that. But first we have to make. Do I even want or need to make an array, or could I just deal with the strings on each line? Somehow store. Oh no, I'm going to have to, because I need to do this for each. For each. All right, let's take a look at what. I need to better understand what we're dealing with here. Is that going to work? Let's find out. Where I put this thing? Go. Okay. So here's an array. And this is the first element. This is the second element. Third element. The question is, do I need to make this into a two-dimensional array, or should I just count the characters? Because strings are technically, I think they have a lot of the same, let's see, MDN string. See, I could use this, I think. Character at. String of cart at method returns a new string consisting of the single UTF-16 code unit located at a specified offset into the string. So it returns the string. Yeah, I think that could work. So we could potentially not bother with making this a two-dimensional array. You know what I'm going to do? Just so I don't have to go back and forth all the time. Let's do this. Yep. All right. So we've got our array. Now we want to start by getting the label. So the label is going to be the very first item, the very first line in our array, so 0. And character at is also going to be the very first one. Yeah, we're going to need a loop too, because I need to... Okay, well, let's start with that for now. If we can get at least to getting the first input as being output as being A2, then we'll worry about iterating that for each line or lane. Okay, so here character. What seems to be the problem? Element implicitly has an any type because type, pause, number, string has no index signature. What? What? Oh. Yes, I'm guessing this is what position number. Yeah. Here we go. Okay. Let's log that just to make sure we've got this right. What am I doing? Console.log label. Okay, so we've got our A. Yay! Now what do we do with it? Switch that back to enter. Enter. Now that we've got our label, we have to look down and to the left and right. So for sure I'm going to need some kind of a loop to do that. For line const line of lines. So here you go. That's what we should call our array. Lines. Oh, gotta get used to the shortcuts. F2 lines. There we go. For const line of lines, what do we want to do? We want to take the line. Oh, and I'm going to need to, I'm probably just going to need, because I need access to the index and all that stuff. So almost never use these loops anymore. Uh, yeah, right. I is smaller than is it width? Our big W here, that should work. I plus plus. Let's just make sure I got this right. It should be lines. Or I could just go like this. Yeah, let's just see what that gives us. Oh. Well, at least I got all of them, but what I wanted was height. Height. And then wait. Okay, we're going to get this. Okay, all right, so we got this. We are going. Does this work? Yeah, okay. Which is kind of silly because I'm just repeating this here. But it'll be easier to work with, I think, if I store it in an array like I'm doing right now. I can always refactor later. All right. So now that we've got that, I guess I don't need the labels here because I can. Let's leave it now for now. Leave it there for now. Okay, what did we want to do? We wanted to look. I could probably do all of that in one go. Not have to loop all over for each label, but just basically all right. The first thing we're gonna want to do is grab our labels and shove that into. Okay, I think I'm starting to form some kind of strategy here. What we could do is first grab each label. So as we're going to the line by line, so on the first line, we grab each label in their position. We could put that into an object or a map, whatever. And so the index or the property will be the lane label, and then we're going to store its position as we're going down. So it's lane, the lane we're at, the lane we're following as we're going down for that particular label. So for instance, to start with, we get A0. B would be 1, 0, 1, 2, 3. So B would be 3, and then C would be 4, 5, 6, right? So A0, B3, C6. And then next line, we'd see if there's any connectors. No connectors, nothing changes. So it's still A0, B3, C6. Then we're going down. And okay, so we're looking for A, which is at lane 0. We look on both sides. Oh, look at that, a connector. Boop, boop, boop. Oh, we're now, A is now at position 3. And we go like that all the way down. And when we get to the end, we pick up which end label matches which lane in the index. And then we get our output. Okay, I think that could work. I think that could work. So first thing is to make, so given that, I think I could probably do all of that right here because this is just, I'm just duplicating here. And I might not even need my array. Do I need my array? I don't think I do. I'm just going to use character at. Let's do this. So, yeah, const. No, I'm going to use a map for this. I think I'm going to use a map for this. So, lane z equals new map. I haven't used a map in forever. How's this work again? Key value pair. Yep. But what do we shove into the constructor? Let's just start with an empty map. And let's type it just for kicks. Our key is going to be a string. Our value is going to be a string. Okay. Now I need to look at each of our var. What is this, 2014? This shouldn't change, so this shouldn't change either. Okay. For let j equals 0. J is smaller than W. J++. Okay. So let's just make sure we're doing this right. So log, we should have our line dot car at j. Yep. Line by line, it's going through. So we got our A, then we got our spaces, then we got B, then we got our spaces, then we got C, then boom, next line. This thing, I don't know what it's called, pipe operator. Okay. Then we've got our connectors and the end labels. I think we can work with this. So this is where we're populating our map. So if, so in the first row, the only thing we'll get, oh, wow, okay. So this should only be happening on the first row. Am I right? I think I am. So if I is equal to 0, not assigning here, okay. So if we're on the first row, here's what we want to do. We want to lanes dot set. Yep. We want to set. Oh, yeah, not yet, not yet. There's another if. If if line char at j is not a space. If it's not a space, then it's a label. If it's a label, we want to add it to our map. I think this is right. Lanes. What would be a better name for that? Lanes label. What is coding game using to? T and B is a single character that can be used randomly. Then assume it will be C. Top. We'll call it top label. Top labels. Top labels. Dot set. The key is going to be basically this here. So I won't be evaluating this twice. Top label equals, okay. Top label set to top label. That's the key, right? And then the value we're interested in is the position, so J. Oh, so actually that's going to be a number. There we go. So let's do that and make sure we're getting what we're looking for here in our map. Top labels. Never printed the map before. I don't know what the output's going to look like. Okay. A is 0, B is 3, C is 6. That's exactly what we were expecting. Good stuff. All right. So what's next? What's next? Now that we've got our labels, we have, oh, let's space this out a little bit because this is going to get crazy with all the if statements. And so once we have that, we need to check. We need to check for each line. We need to check if there is a connector. How do we check if there's a connector? Check left, we check right. Do you have idea big O notation for the solution? Crazy large, probably at this point. Yeah. Inner loops are never, embedded loops are never really good for that. But no, I'm not a big O notation on the fly kind of. I'm pretty sure it's not O-N or however that works again. I showered and I think O-N single pass. I'll just worry with solving this first and then maybe refactor. Okay. Easy to code in the shower. Yeah, I should try that. Not too good for your hardware though. Do they make waterproof computers? They probably make waterproof laptops, right? I'm guessing for like, I don't know, people that need to do computing underwater. All right. So how do we check? How do we check to the left and to the right? Well, we take a look at for each label. So I need to, oh boy, I need to loop. Another loop. A loop inside a loop inside a loop. I need to iterate through my map, my top labels map. Look at each label. Look at each top label, look at their position, their last position, and then look to the left and to the right of that lane to see if there's a connector. So map is, I'm pretty sure it has an iterator. Does it? Entries returns an iterable of key value pairs for every entry in the map. Yes, values. Returns an iterable of values in the map. Can't I just do a for loop on that? Pretty sure I can. If I just do this for let label of top labels. Maybe not. Is not an array type or a string type. Use compiler option, down level iteration to allow iterating of iterators. Alright, whatever. I won't fight you. Hold on. If I do top labels dot entries, that will return an array, right? An iterable iterator. Okay. So I should technically be able to do label of, I'm not going to change that, so okay, of top label entries. No? Is entries a function? Yeah. That didn't work. What? Same thing here. What do you got for me here? Next, return, throw. Shouldn't I be able to iterate? And it shows you how often I use maps. All right, good old trusty MDN. I know there is a way. to iterate. Did I just see for each? What? What? How did I not see this in my IDE? Wait a minute. Top labels, top labels, dot. Ah, there it is. How did I miss that? Ugh. So we'll use that. Value, key, and the entire map is what we can use. So we're interested at this point in both the value being the label, no, being the position, we'll call it. Position, which is, well, I don't think I need to type it here, right? Position, and the key is the label. Or do I need to? Oh no, it's just it's complaining because it wants it. It wants the function. Expression expected. Yes, you expect a lot from me. Position of type number, label of type string. That's right. So what do we want to do with this? Oh yeah, check if there's a a connector. A connector. How do we do that? We look to the left, we look to the right. So let's just start by if position, position. And now we're inside. What do we have access to here? We have access to our line. That's what we're interested in. So line dot char at dot position. So far so good. +1. This will check to the right. So if it is equal to, what is that called again? In French, it's trait d'union. In English, it's, is that hyphen? I can't remember. That thing. If it's equal to that thing, then we know that there's a connector. And what do we do? Oh, well, we change our position, right? So we do top labels, top labels, dot set. Our key is our label, and our new position is position +1. Does that work? Yes, it does. And we do the same thing for to the left. Position -1. Look at all these magic numbers everywhere. Position, oh, it's not -1, it's +3, actually. Right? Because if we're here, then we check to 1, boop, then this is going to be our next position. So +1, 2, 3, yeah. So and this is going to be -3. Well, I'm going to need to fix this because Set our new positions that way. Now the question is, what happens if I am looking at the very first character on the left and I go, hey, check for the position to the left of that, and there is none. Is that going to throw? Is that going to return undefined? So let's look that up. And that way we can defend against that problem. Character at returns a string representation of the character at the specified index. Empty string if index is out of range. There we have it. Empty string. That's even better because then we don't have to worry about it, because really we're looking for the connector. We don't care if it's anything else but the connector, such as an empty string. We don't care. So we don't need to do any more than that. So technically, with what I have right here, at the very end, I should end up with the correct positions for my top label. So let's try that. Let's see what our map has when we're done. Where did I put this thing? There it is. Okay. Okay, and we end up with, that was, well, did you see how long it was to run that thing? A is now at 3, position 3. So that would be this, which is correct. B is at 0, which is correct. C is at 6, which is correct. Okay, getting somewhere. All that we need to do now is check to see if we're at the end. And when we're at the end, we need to match our, there's 2 ways to do this. See, if I didn't care about typing, and I wanted to do this really like JavaScript style, I could just go, oh, well, my map values are going to be either a number or a string, because then I could just shove the bottom. Oh, actually, it's an ASCII character. Right, which is a string. Okay. Yeah, so I could just just keep dealing as I go down line by line, keep dealing with the position, and then once I hit the last line, then I could just go, oh, why don't you shove into the map whatever string you've got at that position. But then we're mixing positions and labels, and so let's not do that. Even though that would work, let's create another value, another container to hold that value. We're going to call that just our final answer. Simply going to be, oh, we're going to make this another map or just a, yeah, let's make it another map. And this one will hold string equals new map. New map. Oh yeah, this will be good too, because we need to print out our answer line by line. So I'm going to be able to iterate over the answer map. Okay. Top labels for each. And we're doing this every time we hit a line, but now we need a final if line Actually, this should be before everything. If line, no, if I is equal to the height. Is that it? Height minus 1, right? Because we're 0 indexed. Yeah. Yeah. So if I is equal to h minus 1, what we want to do at that point is take our answer. What did we call this thing? Answer. So answer dot set. Setting label, and the label will have a value of whatever line. Okay, I should really be getting this even higher. Let's just call this car character. Character. Let's put that here. There we go. If character, so if we're on the first line and the character is a space, is not a space, then we set it. Okay. Now, where was I here? Set label to character. Oh no, that's not right. It's got to be a different one. Why do I need to check this for each character? I don't think I need to. Okay, I'm changing too many things here for now. Let's just rerun this and make sure I didn't screw up anything. 3B0 C6, good. Now, I'm pretty sure I only need to check this on each line. Because I've got everything I need, right? Am I looking for J here? No, I'm not. Yeah. So I could probably shove that here. Not using a character anywhere in there, so let's do that here. Now the thing is, this needs to happen first, yeah. Let's try that. Right, okay. A little better. For some reason, I had this happening on each character, which wasn't necessary. Only needs to happen once for each new line that we're going through. All right, let's try to backtrack a little bit here. So here's a new line. Good. Now we grab for each character. Oh no, I'm still in there, aren't I? What did I do? I didn't change anything. Oh. I don't even need to get. Okay. Got this all wrong. Well, this is wrong. I'm just doing a bunch of work for no reason. Because really, okay, here's our new line. Boom. If it's the first line, so this is where I need to check for this. If it's the first line, then we need to go and grab, let's see, let's get that out of there. We need to go and grab our top labels. So this would be here. That this would be in here. Okay. So that makes more sense. I think I just copied this, right? All right, let's see if I messed things up. See how faster this ran? Much faster. So I had a bunch of work happening inside like a inner loop for absolutely no reason. And we still have the same result. Yeah. All right, so we're checking for our labels. We get our labels. Then for each new line, we just check if there is a connector. If there's a connector, we update our position. Boom. Next line, do the same thing. Now the one thing we need to check is, are we now in the last line? And this isn't the place to do this, I don't think. Maybe, maybe not. We'll see. We'll start here anyways. If I is equal to h minus 1, in essence, if this is the last line, then what we need to do is also maybe it should be happening here because I'd have to duplicate that although otherwise. Phi is equal to h minus 1. Now we need to push to our insert map. We want to set for each label. We want to get the character. We want to get the character, so line dot character at our last position. So we're not interested in the position itself, we're interested in the character at that point. All right. And now we're going to get our answer. See what we get here. Drum roll. All right, A2, correct. B1, correct. C3, correct. Now, all that we have to do is to output this way, and then we'll be done with our first test case. So console, let's see, answer dot for each. And we're really only, what are we, how do we, how do, what's the format again? Okay, just like that. So value, no, let's call it label. And then let's call the other one, no, let's call it top label. Although, is that going to cause a problem? Do we have a top label? No. Top label and bottom label. That, like this. And then console.log. Console.log. This needs to be a string. Oh, actually, as simple as that. Let's just do, what is it? Top label plus bottom label. Top label plus bottom label. And I do believe this should work. Let's find out. No, why? Ha, interesting. did I invert the? Oh, so I'm guessing this is the key should be. What are we? Oh, yeah. So should go here. Should go there. And this should work. Yes, green. All right, play all test cases. See what happens. Boom, 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 boom. Yeah! I am a not so stupid human being. Now, can we refactor this? Probably. Should we? Why not? Let's take a look. What do we have going on here? So this was given to us, but I don't like it. I don't like it at all. WH. Let's use words. Let's use words such as weight. No, wait. What am I saying? Width. Width. And height. Now someone has mentioned to me that capitalizing your const is kind of old-fashioned. And I don't know. I was wondering about that. So here's what we're going to do. Let's look at the convention in the JavaScript world in terms of constants. Google JavaScript style guide. JS guide. Naming. Well, Google's trying. Google's trying to help me. I don't know if you guys heard that. My tablet just ran a Google search. Formatting, white space, grouping, parentheses. Let's just do a search. What is it? F2? No, what is Control F, right? Control F, yeah. Const. Oh, there's a bunch. That's not gonna. Maybe just constant. Oh, there we go. Oh, that's enum. Enum names. Constant names. Constant names use constant case. All uppercase letters with the word separated by underscores. There's no reason for a constant to be named with a trailing underscore, blah, blah, blah. So the convention, in JavaScript at least, seems to be to use capitalized constant names when they are truly constants in the sense of, because I don't use them with every const that I write, because the concept in JavaScript of const is kind of, it doesn't mean immutable, right? Like I could have a const object key and then value, and then I would have to assign that though. Then I could still go ahead and assign something else to this. Foo! Boom, right? So I've mutated the object. But it's still this object that is assigned to obj, which is, I couldn't go ahead and do this. Right, so, but in the case like this, I wouldn't use capitalized constant thing. But when like hard coding strings and values and numbers and things like that, I like to use capitalized naming. So that's what I'm going to do. All right, onwards with the refactoring. What else could we change here? Our inputs. We're not going to change that too, so oops, I always forget about that. Inputs. Although, yeah, you guys can tell me what you think about that if you care to. Okay. We got our map here. We got our for loop. So really in the end, we've got this one for loop that goes line by line, and then inside of that, we're iterating our labels. Not every character, but just our labels. Is there a more performant way to do this? I don't really think so. There's no getting around it. We need to iterate. We need to iterate through those things, I believe. One way or another, yeah. I could break that down into different functions, though. So this would be we're going to call we're going to call that, what are we going to call that? New function. That sounds like a great, great, great name for, well, what are we doing in that function, really? We're doing a few things, that's the thing, eh? We're looking for connectors, but we're also checking for if we're in the last line. We'll just call it for now iterate top labels. For now, anyways, for now. And then maybe we could extract that to a function as well to make it more understandable. Extract to inner function in function iterate top labels, or extract to function in global scope. Well, let's see. What if we do this? Nah, don't like it. Don't like it at all. Prefer this. But then we need to pass in like so many. Nah, don't like that much either. Maybe I could just leave it like that for now. What about this? What's happening here? We're checking if it's the first line, so we could probably make this into a function that we're going to call assign top labels, or maybe not assign, record top labels, save top labels. Let's go with that. There you go. So what are we doing here? We are so for each line, save top labels. Well, we shouldn't be doing that on each line. So the if statement should be outside of that. So really, this here is what I should extract. And call it save top labels. That makes more sense. And if I equals 0, what does that mean? If is first line. Now, if is first line, save top labels. Kind of silly, but it's more readable that way. And then, otherwise, what do? We iterate the top labels. That doesn't tell us much. What we're really trying to do is check for connectors and update the position. Which this is what's due. This is our update position thing here. What if we extract this? When we end up with a bunch of well, that's not that bad actually. So let's call it update top labels position. Okay. And this here we'll call print answers. There we go. Let's try to put that in order of, so the first thing we're using is this here. And then we're doing save label, top labels, good. Then we're iterating the top labels. Really should rename this. Or maybe just split it into two functions. One to check. No, but then I would need to do two loops. That doesn't work. Wondering though. Let's get that back in here. See if there's something better that we could do. I screw something up. Looks like I did. I'm expecting function. What are we missing here? We are missing. We're missing this. Nope. Missing this. This, I mean. Nope. What? What are we missing? Mm-mm. Then we got this, which should be this here. Then we've got our inner, okay. Yeah, should be like that. And like that. Here we go. Okay. Refactoring a whole bunch here, but I'm not running the tests to make sure I'm not screwing things up. Way to go, Phil. Okay. We didn't. Good. So I want to change this. I don't like this. Iterate top labels. This function does too many things. Because it checks to see if we're in the last line. So really shouldn't this be? Oh yeah, I think I tried extracting it out of that top labels for each loop. But the thing is it needs the position. Although Yeah, I could just do yeah. Why did I do it that way? It seems so obvious that it shouldn't be a problem. So let's call this update. Keep forgetting about this. F2. Update top labels positions, right? Yes. And this, we're going to take it out. We're going to check here if it's the last line. And if it is the last line, we just need to do a top labels dot for each. No big deal. Separate. What are we calling these again? We're calling these position and label. Okay. Position and label. Here's our function. This goes in here like that. Okay, good. Good. So we're going to extract that and call this update answer. Update answer, or yeah, let's call it that for now. And this is going to be quite simply is last line. So, okay, let's just run the test here, make sure we didn't screw anything up. It's all working. Great. All right, so for each line, we check if it's the first line. If it is the first line, we save the top labels. If it's not the first line, but it is the last line, we update our answer. Otherwise, actually, I don't need to do this, do I? If it's the first or last line. Save top labels, save top labels. Are we getting the character? If we're saving the top labels, character, top labels is set character, and J we're getting the position, so I don't need to do this. We're doing extra work here. So if it's the first line, we know, it's not a function though. So it's just out in the global scope, so let's use, because otherwise I would have used return, but let's do else if. Else if. Let's do it like that. Else if it's the last line, do that. Right. And then else if it's this, do that. Else if it's none of these two things, else. I just need to do the else like that. I do this. Okay. Let's see if my logic's still good. Yes. Great. That ran pretty quickly too. This is starting to look pretty good. So is first line, then save top labels is what we need. We are to follow the flow. And then is last line. So I got this backwards, is last line. Should go after this. Then update answer, last line, update answer. Then update top label position, update top labels positions. Finally, print answers. There we go. We've added a few lines, of course, to our file, but much more readable. This is it. So just by reading this, you can better understand what we're doing. Although this main loop here is not all that clear that we are iterating through each line. Should we somehow make a function out of this too? That line equal read line. That's why I don't like this type of loop. It doesn't tell us anything. Should I? Or just... No, wouldn't make much sense to do that. Yeah, I think that works. I think we're going to keep it that way. Mm-hmm. Okay. What do you guys think? See anything that could be improved upon, refactored somehow for more readability or increased performance? Well, I don't really care about increased performance. This runs pretty well. All right, running all those test cases in like no time. But maybe just readability. If there was a way to make this a bit more concise or terse while not giving up too much readability, that'd be nice. Oh, I've got this here that is not very... Right. It doesn't tell us anything. Like position plus tree, what is that all about? Somebody was looking at the code and trying to figure out what was that all about. We probably should like extract that into some sort of a constant. What are we doing here? Oh yeah. So 3, we could extract 3 into a const that we could call space between lanes. Yeah, let's do that. Extract to constant in function scope or global scope? Well, let's put it in the global scope. And let's call it, what did I say? Space, or characters between lanes. Or legs, maybe? Since it's called ghost legs. Don't even know what the ghost legs things is about. Between legs. Let's just call it lanes. Character between lanes. Here we go. And this here. Position minus characters between lanes. Where oops. And we could, what is this here? What are we doing? Position plus 1. We are checking that oh yeah, we're checking for connectors. So I should really extract this as well. Extract to function in global scope. I could extract this to a constant in the enclosing scope. Oh yeah. But no. Let's do this. If connector to the right. If connector to the right. No, that's not a good name. If is has connector to, or let's just go, has right connector. Okay, and this will extract to has left connector. So for each top label, if it has a right connector, it has a left connector. And we know that both can't be true, so that's fine. Top labels set label position plus character between lanes. Yeah, that's, I mean, I'm going to end up with 100 lines trying to clean this up and make it more understandable. this could be, actually, I could probably extract this. And call it um, position plus characters, but so that would be right positions or right const right lane position. Okay, now we're setting it to the right lane position. And this, gonna do the same thing. Left lane position. Now this is, yeah, that's clear. Clearer, anyways. Could do the same thing here. Line of character at position plus 1. I'm going to call that at immediate right. Character at immediate right. Yep. And then immediate left. Am I spelling this properly? Whatever. Okay. What's happening with our coding thing here? Still working? I think so. Let's take a look. That didn't work. Interesting. We screwed up something, apparently. I don't see why. Oh, I don't think it's updating. Oh, yeah, it is. Nope. Found A1, expected A2. Kind of messed up something. Might not like this for some reason. How's right connector, top labels? Nope, still. What did I do? Let's bring this back here. Hmm. Very interesting. Control Z is the best debugging tool. That's what happens when you don't commit. Yeah, that's interesting. So what changed here? Move this there. That shouldn't be a problem. No, okay. So what's the next change I made? Character between lanes. For some reason it didn't like that. Do this. It's gonna work. Wow, that's weird. Why? That doesn't make any sense at all. Let's take a look at this again. All I'm doing this is really weird. And it doesn't work. Character between lanes equals 3. Position plus characters between lanes. How odd. So there's got to be something going wrong with the way it's transpiling it to JavaScript here. Function update. That seems right. What would be the problem? What if I try actually putting it inside the scope? I don't see why this would make a difference, but let's try it. I'm curious to see. And that works. Huh. Why wasn't it able to access? Why wasn't it able to access that variable when it was outside the function scope? There really is no reason why that I can think of anyways, that it couldn't have access to it. Anyways, so that works. But now, what if I try to do this again? If has connector, has right connector, has right connector. I'm just going to run the test right away because, okay, so that works. We'll do the same here. Has left connector. sure this all works. Yep. All right, I think that's what we're gonna leave. We're gonna keep that for our final solution. Let's give it a once over one last time. So for each line, first check if it's the first line. If it is, we save the top labels. Otherwise, if it's the last line, we update our answer. Otherwise, we update the top labels positions. Once we're done with all that, we print our answers. Print answers. Yeah, okay, sure. Print answer. Print answer. Print. There's one answer, many lines, but one answer. And all our inner workings is happening here. But the high level flow of the algorithm is pretty easy to understand when you look at this. And that's what I wanted. One last time. Uh-oh. Okay, good. Great. Why did it take so long for the... Okay. All right. Let's submit this. Computing our score. Oh yeah, so what it's doing here is that it's actually, I think, trying our solution with other test cases. So how do we rate this? Was this super fun? Did I love it? Did I like it? Did I just okay? I'm gonna go with liked it. Liked it. Next step. Boom. Oh, could have looked at what other solutions were, but I guess I would have to go back in there. Anyways, so we're coming up on 2 hours, guys. So I'm gonna call it a day for now, anyways. Thanks for sticking around. I'm streaming every weekday morning at 9, and at least for the duration of my 100-day coding challenge. So feel free to drop by again. Take care. Bye.